slash marker. Okay, so if I remember correctly, we have all the entities, so except trees. Basically, we have our player entity, we have the obstacle entities. These are all now in our world, in the entities. So now we need to make sure that we're adding trees into these entities as well. I don't think we're having any errors that's causing them not to load. I think it's more of we're just not calling the code that causes them to try to load and then subsequently draw to the screen. So that's fine. But the idea is that we're going to want to add a tree to our entities here. And so we have this create tree method part of world. I think this is going to want to be like something separate. Because we figure out like what type of tree we want. And then we push a new tree. Oh, and we're either pushing it, like adding it to the front or the back. So that's actually really interesting too, is that we have like what order we want these to be drawn in. That's super interesting. Because right now, okay, so I'll deal with that in like when it becomes a problem. For right now, we just want to be able to create a tree and add it to the world. So right now, that's happening in game where we're registering entities. So it sounds like now we're going to have in draw just sort of a randomized, probably here in when we're running, we're going to want to create a tree and then add it in. So let's go ahead and get ourselves a random chance to create a tree. So if random between, I mean, I guess this already gives us a random number between 0 and 1. So if random is greater than 0 dot, let's say like 8, so that's 20% chance of happening, then we know we want to create a tree. So let's just run, let's just do const tree equals create tree, and then we'll go down here and essentially I think we can copy from world this create tree into the game as a function down here. JM Frank, good morning. You really liked the stream, started with Rust last week and still catching up with this one. Oh, awesome. Well, I'm glad that you're getting started with Rust. I love that language. It's super awesome. Also, I don't know why that reminded me that there was a comment on a YouTube video that I need to increase the font size. So thank you also for that, and good luck with Rust, your Rust journey. I've always found it like, well, it's just such a fun language in my opinion. All right, so we're gonna turn this into a function that creates a tree. We want it to return a new tree, so we have our tree types, our tree data, create tree data. So we call this function random tree type. So of these, we get a random green color, random alpha, random tree color. We create our new tree, and I think at this point in time we can now just return. In fact, we could probably just return straight off of here. Okay, so that gives us a new tree. And then we need to world.register entity the tree. So let's see if this starts creating trees. Oh, no, errors. Okay, so entity.render is not a function. So that means that the tree tree.js doesn't have a render, it has a draw. So let's make this a render. There we go. And so now we have lots of trees. So perhaps this is a little bit too high of a chance of creating trees. It is because it's like 80% every frame. There's 60 frames per second. So this is that's a lot of trees. Let's go ahead and change that. Change this down to, I mean, we want this, if random is greater than like 0.99, like 0.01. It is a lot less. There's still plenty of trees. So you'll notice that they're drawing in front of the obstacles. And that's because they're being added afterwards, and we're drawing from like left to right on that array. That's definitely making this game harder to play, because now, like, hey, our player and obstacles are behind the trees. Well, that's not fun. So now we're gonna have to figure out a way to draw these in order. So I have an idea. We can in the world.render, we're gonna have to loop through. So we're gonna have to add in, not a type. Let's go into world. So in this render, it's just looping through and rendering. I'm thinking we're gonna want to do essentially 2 passes, like multiple passes, and essentially implement our own z-index type thing, where we can say, okay, we want the players and the obstacles to be at the most forefront level. We want the we want the short trees in the next level, and then the tall trees at the furthest back level. So this means, I think we have like a tree data. So here's like tall trees, it's prototype. We also have tree. We can do something like the location in the back, like how far back we want it to be. Z-index might just work. We could just steal that term and use it. So let's start with the trees here. So we want a z-index. This dot z-index equals, let's do the higher the number, the further back. We could also have like three draw planes, 3 draw distances. I kind of like that too. And I wonder if I should use this as a like an enum, where I can just say like, hey, we want it to be the furthest back, like far background, foreground. That way I don't have to remember z-indexes. It's not necessarily part of world here. We want to attach this as a little bit of data. So if I create another file here, and I name this, where did the other stuff? Like there's globals, game state, Yeah, I don't know exactly where the best place to put this would be. Probably its own thing. So this is going to be like the draw distance, the draw plane. So draw plane.js. Go into our index because we haven't set up any kind of like import system. Draw plane.js. Back to draw plane. And so this one is going to be a pretty simple object. We'll just call this draw plane equals and this object here. And so we have only a couple of choices. We have foreground, which we'll just call this foreground. We have background. And we have like scenery, like moving scenery. Maybe it could be like far background. It doesn't really matter what the string of this is because I'm really doing this for the keys. So if I do this, now we should be able to, in the tree, have the draw plane. And we're probably going to take this off of data. So what that means is in tree data, and tall tree, we're going to have draw plane is draw plane dot, what did I call it? Far background. And in just tree, it's going to be draw plane dot background. So say view. Then in this tree, the data is going to come in, and so it's going to be data dot draw plane. So we don't need to worry about what that means here in this point. Then we have the obstacles and the player still. So the obstacle, this dot draw plane equals, let's do, you know what's interesting is this should really be, I'm appending this to literally everything. Everything needs to have a draw plane. Like that's kind of what I'm learning here. So instead of like this, like that, let's actually make this part of the entity superclass. So we have this dot type. We're also going to have the draw plane. And so this dot draw plane equals draw plane. Oh, that's where I put the types. Okay. So I could easily put the draw plane here too. Well, that's not really that huge of a problem. So now when I call super on tree, which we're not right now, but let's do it. So we're going to call super. Tree also is going to have to extend an entity. Entity. For entity, we need the type and the draw plane. So do we have player? So now we need type tree. Okay, so the type is types dot tree, and then draw data dot draw plane. Okay, so we have that. Now let's go into the obstacle. In super, we have types obstacle, and then we're also going to have the draw plane dot foreground, and then the player types player, and this is going to be the draw plane dot foreground. Okay, now in the world, when we do rendering, we can now split rendering into different planes, as it were. And we still want a single. We still are going to want this like single entity vector, because that's going to be super easy for dealing with it. King Milo, good morning. So probably like maybe get the far background first. So const far background. This dot entities dot filter. You know, we could save a lot of time by, instead of doing this 3 times, we could create the we could create an object with 3 arrays in it. So then we could do like, okay, const that way we only have to loop through it. I'm still doing like 3 loops, but that will prevent us from doing like 6 loops. Okay, so let's first create the object that has like references to all the new arrays that have references to what we want to draw out. So these are going to be entities by plane, by draw plane. Equals, okay, so now let's essentially, this is essentially a reduce. So this dot entities dot reduce. We're going to have our sort of like grouping of entities. So groups, and then we're going to have like the next entity. So then in here, we're going to return whatever comes into groups next. So if the entity, and maybe like first let's think about like what these groups should be. They're groups by draw plane. So we're going to have an object that has what do we want? We want foreground, and that's just an empty array. We want background, empty array, and then far background, empty array. So then in here, we'll add whatever this entity, like the reference to the entity, to whichever of these arrays is necessary, and then return the groups. So I think, you know what? Now that I think about it, we do want this to be, where's our groupings? Our draw plane. Let's just make these match. So far background, foreground, background, far background. So they're going to match, which means now foreground, background, far background. Yep. Okay. I think that's all working. So now I can just match to see. I can just put it in the correct spot. So we can do groups of position entity dot draw plane dot push entity. So just push the entity into there. We're not really pushing the real entity, we're just pushing a reference to the entity in. So this is going to be very cheap memory-wise. And then we'll return the groups. And then at the end, so now we have our entities by drawPlane, which is this object here, but it should be filled out. So now we can just do we'll do 3 loops. Here's where we have this.entities.forEach. So we first want to do the entities by drawPlane dot far background first. We'll loop through that. Then we'll do a couple more times. And then another one for the background, and then finally the foreground. Can't access property push groups entity drawPlane. Need it spelled correctly. Far background, this dot entities by drawPlane is undefined. Hey, this error message has improved and changed. It used to be type error can't access property far background of undefined. So now it's letting us know exactly what's undefined. So right here, right, because it's no longer this. We just want to use that. I do need to be clicked into here if I want to jump. So the trees are drawing, I believe, in the correct order now. Yep, and the obstacles are all in front of the trees. So this is perfect. Our drawing is now in order. And so we could do things like limit the speed. We could add new obstacles. We could try to calculate out like how far past to put the obstacles. We could add, like, there could be other things we can add, but I think for this specific update that we did, I think we're done with the JavaScript side. So let me go ahead and close this window. Let's go ahead and open up Get Kraken. And let's store this all up here. So we, oh, you know what? We have forgotten something. So let's see. Trees are entities and are drawn in the correct order. But before I completely sort of go back, open this back up again, I have forgotten we need to remove the trees. After they leave the left-hand side of the screen, we need to delete them. And that's going to be a problem because, well, if we don't delete them, it'll be a problem because eventually we'll just fill up our memory. We're creating trees infinitely, and we don't want to do that. So let's go ahead and, so here's my thoughts. We want to call, like, remove dead entities at the end of this. So here in game, we're going to want to do something like world.remove dead entities. So that would be something like in world, we have remove dead entities. And in the game, at the beginning here, we want to, okay, so we randomly create a tree. We also want to now just do world remove dead entities, like that. Obviously nothing is happening yet because we haven't done this. Let's go ahead and Where are we doing? Is player hitting obstacle? Let's just remove this notification event. That way, we could just run through all of the obstacles, and we don't have to worry about that. So what we want to do is, as soon as this tree moves off the screen to the left, we want to mark it as dead. That means in the tree, so the world's going to have to remove all these entities that are dead from its list of entities. Tree is going to have some kind of like is off screen. So it does that. It has this is off screen. I think what would be better is to mark this as an is dead. So if we do this as like a get and change this to is dead, now we can just do tree dot is dead in an if statement. It'll return a Boolean of if it's off the screen. And that means in world here, when we're removing the dead entities, we want to essentially just filter out all the entities by this. So we can just do this dot entities equals this dot entities dot filter. We're going to get an entity, and we're going to filter by entity dot is dead. And that's actually not a it looks like a property, even though it's a method, but it's a getter. So we can just say, hey, look, if the entity is dead, so this is what's returned here. If this is true, it's going to we want this to be the opposite. So let's do not is dead. If you're not dead, then you're going to survive the filter and you'll be added into here. So we'll save this. And now we should see the trees. We create them. I wonder if we can see the memory usage. I don't know if we're going to see like it going down. This might be something where we can console log the world size. This isn't really helping me like in memory usage, like figuring out. Let's get rid of that. Like there's just snapshots. It's not. I take multiple snapshots. Well, that's not. I mean that's cool. I could see like probably all the entities and everything, but that's not what I want either. Let's instead, in our main game here, while we're running, let's go ahead and console.log world.entities.length. Bare Knuckle Waffle, good morning. So I'll save that. We'll come back to our console. We have five trees, 9 trees, 10 trees, 11. Okay, so 9. So now they're disappearing. So we're losing all of our entities over time as they're removing from the screen. So that's perfect. Then that is working. All right. Then that is the end of what we're able to do with the JavaScript and P5.js side. Let's go ahead and add you in. Store your changes, which is Nested entities are removed every frame. Okay, so I'm gonna go ahead and push that code up. I have a link to that code with the bang repo command. So if you want to go check that out, it's in the P5.js directory. And let's go ahead and maybe go take a look at what we've got on the Rust side. This is all very interesting to you. It's been a while since you've done some JavaScript. Does you mainly do Python and C++? Yeah, JavaScript is a super, like, I think it's like both Rust and JavaScript are fun languages to me. It almost for the opposite reasons. JavaScript just lets you do whatever you want, and Rust like doesn't let you do whatever you want, and it's like incredibly restrictive. But because I use both, like whenever I feel like, oh, well, Rust is like being just too mean to me, I have like, well, let me just go do something where the language just lets me do whatever I want. So let's come back out. We'll go into the GGZ infinite runner and open up this infinite runner. Oh, you're finding JavaScript quite hard to grasp. It can be it's such a different language that you have to like almost treat it like as a completely different type of language in your mind. I guess like I could almost see that like Python might do that to some people because they're so used to semicolons and brackets and everything else. It would be the same type of thing of going to Python from Java or C or something like that. There's a lot of things to learn that aren't necessarily programming related. And asynchronous programming is a thing. All right, so let's go ahead and take a look at what we've got here. I want to do a cargo run and just see what our game state is. Your first language was C++, then going to Python 3 was hard. Yeah, I can imagine that. So here we have pretty much the same game. There's some like small stylistic choices. The speed is slightly different. We just updated the speed last time that we were in this game. But we want to now put the update method into this game, as it were. Async and Python, welcome to zombie code. I've done only a little bit of Python in my time, and it was not async, the stuff that I coded. So I could imagine it would be pretty bad. All right, let me go ahead and